Hello everyone, in today's video we're going to be taking a look at setters and getters, aka mutator methods inside of Python. Now one of the things you probably remember from the previous version in our previous program there is we built some basic classes and we started modifying some of their internal values, so those attributes that they possess. Now this can cause some very interesting problems depending on what it is you're trying to achieve in a program. It can also put you in kind of a nasty spot. Let's go ahead and demonstrate that. So what I'm going to do is I'm going to create myself an element class, and I will keep this nice and simple, defined in it, just like always. We're going to have a name of my element here, and we're also going to have a density of my element here. Now, I'm going to go ahead and put some quick default in element. Why not? And we'll go ahead and give it a default density of 1.0. So what we're going to do here is we're going to go ahead and take these things that we use from our constructor and jam them into the instance of the class. So I'm simply going to do self.name equals name, and I'm going to do self.density equals density. Fantastic. Nice. So let's go ahead and create ourselves an instance of this class. So we'll use gold because gold's kind of a nice thing. It's a pretty substance. It's a easy density to remember how stupid dense it is. Let's see. Gold equals element gold, and our density for 19.32. It's pretty good. I like that. Nice. So now we're ready to rock. So if we wanted to go ahead and get some values out of there just for testing, I could say print gold.name just like that. If I were to run it, should say gold. And of course, if I wanted density, we could come in here and do gold.density just like that. If I were to run it, bam, fantastic. Everything is working great. Now, let's say I wanted to do a little bit of math. This works pretty well. Quick test. I'm just going to leave myself a note there. Let's do some math. Let's see volume. I'm going to just go ahead and do this. We'll do gold.density. And now we're going to multiply it by, let's say I have, I don't know, 5 units of this kind of thing. Print. The volume is a volume. Fantastic. How loud is the volume? What is my volume? What's your volume? Now, if I were to run this, of course, it'll say the volume is 96.6, which, of course, I haven't attached another value to. I'd have to come in here. In this case, I believe it's kilograms, if I recall correctly. So this works pretty well. It's kind of works. It kind of works. I like this. So let's go ahead and make ourselves a new element here. We'll do, let's see what's a nice little element here. We'll do iron. Iron's pretty good. We'll go ahead and create another one. We'll call this one iron. Iron density. I gotta go look that up. Shoot. The worst part is I actually kind of remember this. So the density of iron is that. And let's say we made a mistake. We actually want to go ahead and take that iron. We want to modify its density. Sounds good to me. So you come in here, you type in iron.density, and you do something like this. Cool. Let's go ahead and do some quick math here. I'll go ahead and grab that content that we had from before. We're going to use iron.density here. I'm going to type in iron. You're going, don't do it. Don't do it. And I go ahead and run that sucker, and of course it works beautifully. The reason it works beautifully is because we can take 5, and of course you'll notice here that the math did not work correctly. And of course the reason the math did not correctly is because we took a string, jammed it into density, which of course it didn't care. It just took whatever you want. That's one of the fun things that we have inside of Python is we can get away with stuff like that, transmutation kind of a deal. So that's not good. And it's actually very dangerous because it now means I can change the value of this particular object all the time without any built-in protection to basically protect us, from accidentally doing something like this. Now, if of course I went in here and said red, actually, no, that's going to work too. Let's leave 5 in there, but let's we'll have some fun. We'll do 0.5 and run it. Whoa, cancel. So if I run this one now, whoa, cancel, cancel, cancel. Everybody stop. If I run it now, it's going to explode because you can't multiply a string by a float. So you can see exactly how dangerous it is to set up a variable where you can basically change it like that. Well, one of the nice things is we can actually design our programs to prevent that from happening. Let's go back up to our class real quick. So what I'm going to do is I'm going to design a setter and a getter, basically something that allows us to edit the internal values safely. So I'm going to go ahead and give myself an enter here, type in def. I'm going to go ahead and do set name. I'll take a copy of self because we're working on an instance here, and I'll say new name. New underscore name, I like that. And I'm going to go ahead and say self.name equals new name. So this now means I can take whatever name I feed into this parameter here and then shove it into my new thing, basically allow it to change. Since we're dealing with strings here, I'm not really worried about that. So for example, if I came down here and let's say I want to make an element X, for example, I'll do a new element. I'll call it X. Well, we'll call it Z for now. And let's say its density is 5. We'll do 64. It's a very dense element. So now let's say I want to modify the name of element X. I can simply type in element X dot set name Now, the nice thing here is because I'm using this as a setter, it's going to be a little bit more protected. So now if I were to come on here and say print element x.name, we can go ahead and get its name. As a matter of fact, if I run it, you can see that it gives us the x. You're saying, that seemed like a lot of extra typing. That didn't. I feel like that didn't have much of a purpose. Like, what's the point? Well, remember our example a few moments ago where we took that lovely density and we basically fiddled with it and we broke it and it was a big nasty mess? Well, this is a great time to show you why these are useful. So what I'm going to do is go ahead and create a new one, call it set density. New density. And what I'm going to do is I'm going to explicitly check to make sure I didn't goof up. So I'm going to use something called isInstant. So I'm going to say, let's see here, if isInstance, this would be the name of the variable, density, float is the kind of thing we're looking for. Then we know everything is correct because the density has to be a float in order for it. It could be technically an integer. Shh. We could actually say or int here if we want it to be silly. But isInstant of density is a float. We know that we sent it a float versus a string, for example. So now we can actually set the value. We can say self.density equals, and we could just say new density because we know the fact that it's a float. Else print, you sent me the wrong kind of value. Now, watch this. Now, if I were to come down here and give myself a little bit of room, let's do element x again, dot set density. And I'm going to do, 64. That's pretty, actually, it's been really nasty. Let's do negative 64 in quotes. Watch this. You will notice I now have generated an error message that says you sent me the wrong kind of value. It is smart enough not to try to change its density now if you sent something like that. That's doo-doo. Fantastic. Now, if I try this again, I'll do element x.setDensity, and we'll say it's 6.4, because why not? If I were to run the code this time, you will notice that it actually executes. So well so that if I were to come up here and I'll borrow my little calculation that I did a moment ago, you'll see volume equals iron.density. We'll change this to element x.density. Element x.density times 5. We'll be careful here. We'll do 3.5 to mix it up. Now, if I run it, look at this. Ding! You can see that it worked perfectly, and there's everybody's favorite floating point errors chilling at the end of that long string there. Well, long number, I should say. So you can immediately see that's actually pretty darn useful because now I have a way to prevent the user from accidentally. I agree with you completely, which is one of the reasons why it is so useful to build this. Now, there are other things people can do as well. Now, let's say I want to go ahead and create a really, really simple method that just returns the name. So I'm going to say def, so let's see, this would be get name. And of course, we can only send a copy of ourselves. Print the name of the element is, and we'll go ahead and grab that self.name. Now watch this. If I were to come down here and do element x, and now I were to attach get name to it, watch what happens when I run my code. You will see here the name of the element is x. Now, this is actually a really, really not good name for this because what I've really done is I've taken the element and I've basically made myself a little kind of printer down here to sort of show you what it is. That's not really what getting name is. Getting name would be returning the name of the element. So let's go back up and change that. So I'm actually going to come down here and I'm going to type in return name, just like that. Self.name. I'm sorry, I should be a little more careful there. Self.name. Now, if I were to come down here, I'd have to actually print this. Otherwise, we're not going to get anything. Print self.getName. Now, if I run this code, you will see, ta-da, there is that name value. Now, you're sitting here going, isn't this exactly the same thing as this? And doesn't this look a little bit cleaner? No, I did it again. Aha. If I go ahead and run that there. Yes, it is exactly the same thing. Although, when we do it this way, you're not going to be having all those enhanced protections basically built into it, which is why we want to do it that way. Now, if I come down here, I could go ahead and do one of those for density too. I could get density. Self obviously is what we're going to do. Return self.density. So now we actually have the ability to get that density directly without reaching into this actual variables that we have saved here. So now what's so cool about this is if we were to come down here, we could do something like this. Volume equals element x dot get density. Watch out for this part now. Times 7.8. I don't know. I'm just experimenting here. We'll grab that value, print that right there. If I press the green button, you'll notice the volume is 49.92 kilograms. So this is mathematically the same as this. However, this is much safer because you're going to have those other protections. Now you're sitting here going, Okay, so I get the general gist here, but this still seems a little silly. Like at any point, I could just reach in here and grab those variables. Is there something else we could do to maybe like make this like a little bit safer? And the answer is yeah, there is something else we could do. But for the purposes of that demonstration, I'm actually going to have to kind of break everything apart here because otherwise we're going to have some fun issues with this one. You can see that all there if you want to sync back to it. So how are we going to solve this? We need to stop people from being able to do goofy things where they basically, actually we'll grab this one because I like this one. Boop. That's good. We want to stop people from being able to do this because we can just get it at any point. How do we force them to use this? Python has a built-in helper. And the way that this works is actually pretty cool. All we do is we go to our variables that we're going to be using to kind of hide them. Again, we're hiding. We're not making them disappear. And we're going to attach an underscore to the front of it. Now, when we attach an underscore to the front of it, we are telling the Python, their actual code down here, to try to hide it. So now if I come here and I say gold dots, and I do gold dot name, you'll notice it's gone. Now, what if I wanted to print gold dot name? Well, this gets a little bit tricky because now we have to remember every case that we put an underscore, we have to including these two down here as well. So now if I were to come in here and say print gold.getName. Oh, densities too. That's not what I wanted though. Get name. Thank you. If I run this, you will see gold. Even though if I type in this, you're not going to see name appear as one of my options of items that I can get. Now you're sitting here going, oh, that's actually pretty clever. That can definitely stop people who are basically working on your code from accidentally like breaking in and like snapping things and breaking them and doing all sorts of nastiness. And the answer is yeah, and that's actually one of the cool things that you'll do here. However, Python experts out there are going to know that this is only hidden. It has not been blammoed out of existence. Watch this. Gold dot underscore name. Now you're sitting here going, but that's protected. It still works. And the reason it still works is like I was saying, all you're doing is you're hiding it, trying to prevent people from accidentally. This is simply a convention built into Python to discourage people from trying to do items like this. Now, one of the cool things is if you're in PyCharm like me, if you hold your mouse over there, it actually says access to protected member name of a class. It's even yelling at you saying, hey, if you're going to do that, just to use the get name, grab that accessor that's up basically right there. And you can see that that's pretty much ready to go. Now, the cool thing here is there's actually one more thing we can do with these little underscores here. If we absolutely have to protect somebody from being able to do this at any point, we actually can go a little harder on this. So now if I wanted to, I could put an extra underscore in front of it. Now, of course, if I do an extra underscore, that also means I have to go down here and fix all these. Now, this is an interesting piece. Not only am I hiding it, but I'm going to be protecting it. So now if I go down here, let's see, this should still work mathematically. Yeah, it should still work. So if I were to come in here and say gold dots underscore name, if I were to run this code, you will get an angry error. It will not allow you to access that value no matter how hard you try. The only way you can get at this value now is by creating yourself this little getter that allows you to reach in there and snap it. Now you're probably sitting here going, okay, I get where you're going. I sort of understand why you'd have something to basically obfuscate. I'll use a fancy word there. The purposes of this class and basically make it protected. This is something I should do all the time. That is up to you. You are the programmer. One of the things you probably noticed if you've been fiddling with things like string, if I go like this, you can see just how often they use the double underscore notation here to basically conceal different components of it. So I can't do s.double underscore sub, for example, though. That's not something I'm allowed to do. But you can see just how often the actual programmers will take the time to actually build these components in there to make it safer for people basically to program and not accidentally. Basically, you're creating errors to prevent worse errors. Enjoy.